Today our topic is time domain analysis of first order RL and RC circuits. Okay, RL not R suffix and RC circuits. So here why we are calling it as first order means because how many energy storage elements are there, based on that we are giving the order. So here only one energy storage element is there, that is only inductor, and here also only one energy storage element is there, here it is the capacitor. And we know that whatever the energy stored is there, immediately that energy cannot be discharged, it is taking some time to discharge. So it is depending upon the time interval. So let us see here, coming to the thing. Here this we can close the switch or we can open the switch. So closing the switch or opening the switch, those switches, that means whatever the in the network, whatever the closing the switch or opening the switch, those switches at that time we are calling it as initial conditions. Okay, so before closing the switch we are calling it as t equal to 0 minus. And immediately if you on the switch we are calling it as t equal to 0 plus. So t equal to 0 minus is nothing but whatever the previous value is there, that will be the past history. Okay, so whatever the past history of the storage element is there, it will be stored with some value. So you know that just by example, mobile phone, if I consider, suppose 60 percentage of battery is there, we cannot discharge that 60 percentage. That means some value will be there, that whatever the value is that value slowly it is going to discharge based upon the usage. So let us see what will be the initial conditions for resistor, inductor and capacitor one by one. Okay, so let me consider first R. Okay, we know that resistor is the symbol. Okay, this is the resistor, and we know that what is the voltage for resistor. According to Ohm's law, V is equal to I into R. So V is equal to I into R. There are no current dependent here, there is no derivative part in the current. So clearly we can say that whatever the voltage is there, it is directly depending upon instantaneous values. Okay, instantaneous values of the current. Okay, and hence there is no change in the behavior of the resistance. That means before the switch, that means switching before t equal to 0 minus is there, no, switching before and after the switch, that means switch is on, that means immediately after t equal to 0 plus, there is no depending upon the time interval. So that is why the resistor will be resistor itself. So there is no change of resistor position. Whereas coming to the inductor case, what is the inductor is represented by coil, and we know that in inductor if we pass current, there will be an induced EMF that is given by V is equal to L into di by dt. And we know that if I pass a DC current, that means DC current, if I apply d by dt of this DC is nothing but constant, no, we know that constant DC value is constant magnitude. So derivative of constant is 0. So derivative of constant is 0, we will have V is equal to L into 0. If V is equal to L into 0, what is the voltage? 0 volts. So if it is 0 volts, what about the inductor? Inductor is replaced by, that means here V is equal to L di by dt. Whereas this is the final condition, inductor, because of the DC supply, what happens, it is a voltage drop is 0. There is no voltage drop, means simply inductor is replaced by short circuit, because in short circuit only voltage drop is 0. That means inductor must be replaced by short circuit. But the thing is, here before the switching, this is the time taking infinite level, no, but the inductor is storage element, no, inductor is a storage element. Because of that parameter, what happens is it is consisting of some previous value, because it stores the energy in the form of magnetic field. So it has some energy. What will be the energy? Let us see with this. Let me clear all first. We know that we know that inductor formula, we already, V is equal to what? V is equal to L into di by dt. What about current? Current I is equal to, I is nothing but I is equal to, if we take I, that means integrating on both sides, we will get I as 1 by L integral V dt. But the thing is, it is depending upon time, no? It is depending upon time. So let us take that it is infinite, minus infinite to some t. Okay, and I am considering as current as IL with respect to t. Okay, IL of t, 1 by L minus infinite to t, and the drop here, inductor drop, I am considering it as VL into dt. Now the thing is, already we said that we can make the switch before switching on, means before the switch and after the switch. So let us, based on that, I can divide this time interval into two parameters, minus infinite to 0 minus, that means before the switch, 0 minus, plus I can write like this, 1 by L integral 0 minus to t VL dt. Okay, this is the thing we can split into two parts, because 0 minus and 0 minus is there, I can splitting into two parts. That means this is 0 minus means what? 0 minus means past value, no? 0 minus means past. This is the past value will be past itself. So here I am writing this term as, because how it is just like a current only, no? 1 by L integral minus infinite to t VL dt. So which is nothing but a past value, I can represent simply as I current I before, that means IL or IL 0 minus, I am representing this as IL 0 minus, plus 1 by L, I am writing this equation as it is again, 1 by L 0 minus to t VL into dt. So this is the equation I got. And see here, this is IL, okay, and this is the past current and this is the present. After switching on, we got this value. Now the thing is, I can split this one, I can write this integration. Now VL is there, VL is a finite. Suppose if VL is a finite value, if it is finite value, what happens? If it is a finite value, that value, finite value means it is a constant, then I will get as IL past current, that is 0 minus, plus, and what is the finite value? Finite value means VL, I can take it out, L integration of 1 dt. So integral of 1 dt, what? Integral of 1 dt, this is 0 minus to t, integral of 1 dt, integral of 1 dt is t only, no? Okay, integral of 1 dt is t itself. Okay, up to here. Let us now write these terms. I got these terms now. Now let us substitute the values as 0 minus to 0 plus. That means when the switch is on at t equal to 0 plus, I am substituting t equal to 0 plus. T is 0 plus means switch is on. What will be the value now? This is IL of t, this is the current IL of t is equal to, this is done. When switch is on, t equal to 0 plus, IL 0 plus is equal to, IL 0 plus is equal to, this is IL 0 minus plus VL by L, and this is the integration 0 minus to 0 plus 1 dt. And we know that if we do the integration, 1 dt is nothing but this term will be same term I am going to get. And what about this VL by L? 1 dt is nothing but a t itself, and if I substitute the limits, it is 0 minus to 0 plus, 0 minus upper limit minus lower limit, if we do, this term will become 0. Only the thing is, I am going to get only this part, that is IL 0 minus plus 0. That means IL 0 plus is equal to IL 0. That means this is 0 minus is nothing but I naught, or simply I can write it as past current, no? I can replacing by I naught, that is the past current. Okay, you can see here, that is the I naught. We are getting two parts, no? One is I naught, another one is current at 0. And how these two are current sources only, no? So this is the current source and this is also a current source, but it is a open circuit. That means inductor is replaced by, we can replace this inductor by current source in parallel, because current division takes place in parallel circuit only, no? So that's why I am taking this is the open circuit because it is 0, it is open circuit and current source. So inductor is replaced by current source in open circuit. That is the when the switch is on. When switch is at a time, that means t equal to 0 plus case it is. When t equal to infinite, we are getting that inductor is replaced by short circuit. But in this case, we are getting inductor is replaced by open circuit. So this is the current we got. When IL is not equal to 0, when IL is not equal to 0, we are getting this case. Suppose when IL is equal to 0, that sorry, I naught is not equal to 0, this is the case we got. Suppose if I naught is 0, that is note 2. If I naught is 0, what about I naught is 0? If I naught is equal to 0, IL 0 plus will be, that means when the switch is on, we are going to get both the circuits as open circuit. That means simply inductor is replaced by open circuit. Inductor is replaced by open circuit. That means here initially it is open circuit. After some infinite time, inductor is replaced by short circuit. This is all about inductor. Now let me clear all these things. So clearly we can say that inductor is does not allowing any sudden changes in the current. Yes or no? Because initially it is behaving like open circuit, then it is becoming short circuit. Now coming to the capacitor picture. What about the capacitor picture? We know that capacitor voltage. What is the capacitor voltage formula? Capacitor V is equal to 1 by C integral V 1 by C integral I into dt. 1 by C integral I into dt. Here from this we know I can find I is equal to C into dV by dt. Previously we used for inductor, now we are using for capacitor. So similarly voltage, DC voltage is applied here, no? If a DC voltage is applied, what will be the current? This voltage is constant, no? DC means constant voltage. So constant means if we see d by dt of constant, d by dt of constant, which is 0. C into 0 is 0. That is nothing but current is acting like open circuit at final condition. This is final condition. But the thing is, this capacitor is initially stored with some charges. No, we will see that one. Okay, this is the final value, and it is acting like a open circuit. Okay, it is acting like a open circuit. Now we will see the past history is considered. When you consider the past history, that is Vc of t, that means this voltage equation with respect to time, if we consider, that is Vc capacitor voltage of t is equal to, what is the formula you are having? 1 by C, the same formula with respect to time interval I am writing minus infinite past history to present t into I dt. So let us apply. If you do here, when you expand this, we can split this into two parts, no? If I split, what you are going to get? 1 by C integral minus infinite to 0 minus I dt, minus infinite to 0 minus I dt, plus 1 by C integral 0 minus 2 t into I dt. So I got two terms. Okay, I got two terms. 0 minus is nothing but past only, no? Before switching, that is past history. This is past history, and this is t equal to, this is the equation I got. Okay, now I can substitute t equal to 0 plus, no? That means when switch is on, if I substitute t is equal to 0 plus, what will be the equation? This is Vc of 0 plus only, no? This is t is 0 plus means 0 plus, and this past one I'm considering as V naught. Okay, because it is a voltage formula only, no? Past voltage, that is V naught plus 1 by C integral minus infinite, sorry, this is 0 minus to 0 plus I dt. So I is a finite value. If it is I is a finite value, I will come outside. We will have V naught plus I by C, I by C. If it is a finite value, I is a finite value. Finite means constant value. I is outside 1 dt. 1 dt is t. For t integral, if I apply the limits, for t, if I apply the limits, 0 minus to 0 plus, upper limit 0 to 0 minus 0 is 0. So this total term will become 0. Only we will have V naught. Okay, the voltage is V naught only. This is the term we are actually getting. Vc of t is 0 plus is V naught. Okay, that means past value only, no? Vc of 0 plus is means It is depending upon past history. That means clearly we can say that capacitor does not allow any sudden changes in the voltages. That means here the final it is acting like current what we got 0, but here we are getting some voltage, no? So what happens to it? Let us check it now. Let me clear all these things. Here what we got, two things, no? That is v naught and other term is 0. Two voltage sources we got, and how they are indicated with plus. Plus means they are added. That means voltage source summation takes place only in KVL, no? Kirchhoff's voltage law, that is in the loop only we can add. So that's why we can split into two parts. So this capacitor, this is the capacitor actually. Capacitor means same parallel lines we need to take. Two parallel lines I have taken. This capacitor is replaced by, if V naught is equal to 0 place and V naught equal to 0 place. If it is not equal to 0, that is V naught plus 0, that is voltage source V naught. This is V naught, and plus 0 is nothing but short circuit only, no? Short circuit, which is voltage is 0. Suppose if V naught is equal to 0, if V naught is equal to 0, what happens? 0 plus 0. Simply capacitor is replaced by no voltage. No voltage means short circuit, normal conductor it is. So short circuit is taking place. This is total thing is short circuit. So short circuit is there. Initially, actually final value is open circuit, no, but here we got as short circuit is equal to 0. Let us take all the things in one table. So we are just now we discussed that resistor will be resistor itself, its initial condition and final condition. What about inductor? Inductor we got as current source in parallel with open circuit. If a current source is not there, suppose current source is 0, means simply it is a open circuit. But finally what happens? Inductor is replaced by short circuit for DC, and capacitor voltage source in series with short circuit. Finally we are getting open circuit. Suppose if it is voltage source is also 0, means actually it is a total short circuit case. That means from short circuit to open circuit, that means it does not allowing any sudden changes. It is taking some time. That is why it is short circuit to open circuit. Is it clear? Thank you. Let me off.